This is example 3 from section 2.11. So in this piecewise function, we have the function changing at x equals 0, so we will definitely check the discontinuity at 0. But we also have some non-permissible values again. So everything at 0 and less than means I'm going to go to the left, and this one here I'm going to go to the right because it's greater than. Also, I'm going to simplify this function, take out a 4 GCF, and I'm going to factor the bottom. So I'm going to get x minus 4x plus 2. And I see that the non-permissible values for this function is at 4 and -2. However, are they both in my domain? So you got to remember, I'm only looking for x values that are to the left. So I can eliminate the 4 because that's not in my domain. So I will check -2, I will check 0, and if you notice, I have no non-permissible values here because I don't have a denominator. It's just a polynomial, a quadratic. So we have two values to check. So I'm going to check x equals 0 first. All right, so the first thing I'm going to do is evaluate the function at 0. Because it equals 0, I'm going to use the first function. So I'm going to plug in 0 wherever I see an x. And I'm going to get positive 8 over -8, which is -1. Then I'm going to calculate the limit as x approaches 0 from the right and from the left. So from the right, I'm going to use the greater than, which would be x squared minus 2x. And from the left, I'm going to use 4x plus 8 over x squared minus 2x minus 8. And I'm going to substitute 0 into both limits. When I substitute it into the limit of 0 from the right, I'm going to get 0, and we already know this is -1. So looking at the left and right hand limit, I can see the limit as x approaches 0 does not exist. The third statement would be f of 0 does not equal my limit, which has shown above. And I'm going to make the statement f of x is discontinuous for that reason. And you can even say one step further, because the limit does not exist, this is a non-removable discontinuity. At x equals 0. So even though the function is defined, the limit does not exist. Then I'm going to check one more value, which is -2. F of -2 equals, which function do I choose? I choose the one that's to the left, which is the simplified when I factor, but when I plug it in, I know that I'm going to get 4, -2 plus 8. I'm going to get -2 squared minus 2, plug in -2. I'm going to get 0 over 0, which is undefined. Undefined, but I can also notice that the limit is going to work because I know that one of my factors are going to cancel. So the limit as x approaches -2 of 4 bracket x plus 2 over x minus 4x plus 2. There's my factors canceling. And when I substitute it back in this time, I'm going to get 4 over -6, which reduces to -2 over 3, which means the limit does exist, which verifies that it was a pod. However, because it's a pod, it means it's discontinuous. So the third final statement is f of 2 does not equal the limit as x approaches -2. Therefore, the function is discontinuous. But you make one more statement and say it's a removable discontinuity. And I know it's removable because it's a pod. And that's it.